Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B1825, relates to a slide pulse error, indicating that there has been no change in the seat slide pulse for a duration of 1 second. This issue can impact the functioning of the power seat adjustment system within the Honda Odyssey models from 2011 to 2017. The power seat adjustment mechanism is a critical component, allowing users to adjust the position of the seat for comfort and safety. Typically located under the driver's seat, the power seat control system includes a slide motor and multiple sensors that relay information about seat positioning. When this DTC is triggered, it typically suggests that the seat slide switch has been initiated but does not progress as expected. Understanding and addressing this error is essential to ensure proper seat functionality and overall vehicle comfort. DTC B1825 signifies a slide pulse error, which occurs when there is no change in the seat's slide pulse for over 1 second during operation. This situation affects the power seat adjustment mechanism, a key feature for the comfort and convenience of passengers. The error typically arises when the operator attempts to move the seat using the switch, but the seat reaches its limit without additional pulses being detected. The key components involved include the power seat control unit, the slide motor, and the position sensors interconnected via corresponding connectors. These components are usually situated beneath the driver's seat, where they manage the electrical signals necessary for the seat to move. Hence, visitors should understand that while the system may seem operational, the DTC indicates potential underlying issues that require inspection. Several potential causes can lead to the activation of DTC B1825. The first possibility is a faulty power seat switch that may not properly relay the signals needed for motor operation. If the switch is defective, it will fail to transmit the necessary adjustments, thereby resulting in a slide pulse error. Another common cause is a defective slide motor that may be unable to respond adequately to the commands provided by the control unit. This malfunction can restrict the movement of the seat, further triggering the DTC. Additionally, wiring issues such as poor connections, frayed wires, or shorts can interfere with the circuit, preventing proper communication between the components. Inspecting the wiring and connectors is paramount in diagnosing this error. Hence, understanding these causes is vital for precise troubleshooting. When DTC B1825 is recorded, it's typically accompanied by specific symptoms that indicate power seat issues. One common symptom includes the seat not adjusting properly, where the operator may notice that the seat fails to move at all or only moves intermittently, causing frustration. Additionally, the power seat indicator may illuminate on the dashboard, informing the driver that an issue has been detected within the seating system. Other potential symptoms could include unexpected power loss or responsiveness issues, leading to erratic seat movements or failure to function. It is essential to monitor these symptoms during daily operations to address issues promptly. Ignoring them could lead to further system malfunctions or safety hazards. The first troubleshooting step for DTC B1825 is to clear the Diagnostic Trouble Codes, DTCs, using the Honda Diagnostic System, HDS. This process involves connecting the HDS to the vehicle's onboard diagnostics and selecting the option to clear any stored codes, including B1825, from the system's memory. When DTCs are cleared, it allows technicians to reset the system and can sometimes resolve minor transient issues. However, it's essential to ensure that the clearing process is appropriately conducted to maintain data integrity for future diagnostics. After clearing the DTCs, the technician proceeds to perform another series of checks to determine if the error reoccurs, enabling proper diagnosis. In this step, you are required to turn the ignition switch to the lock position, which is marked as 0, and then turn it back to the on position labeled as II. This action serves as a reset for the vehicle's electrical systems and ensures that the power seat control system initializes correctly. By cycling the ignition, technicians can ascertain whether electrical signals can be properly transmitted to the seat motor and its corresponding components. This step is critical to preparing the system for the upcoming operational tests of the power seat adjustment mechanisms. Ensuring the correct ignition positions is vital in this troubleshooting phase to avoid misleading results. The next troubleshooting step involves operating the power seat adjustment switch for several seconds in both forward and backward directions. This action is aimed at evaluating the seat's motor response as well as the overall function of the adjustment mechanisms. When performing this test, technicians must closely observe how the seat responds. It should move smoothly without any interruptions. If DTC B1825 presents itself after this operation, it suggests that the switch has been engaged long enough to deactivate the signal momentarily, indicating a problem even when the system may be functioning. This step is pivotal to assessing the reliability of the seat slide assembly and identifying any irregularities that could indicate faults. The fourth step involves checking for DTCs using the Honda Diagnostic System, HDS. Once again, this analysis is focused on verifying whether DTC E1825 remains present following previous operations. If the system indicates that B1825 is still active, it confirms that there is an ongoing issue with the power seat adjustment mechanism that needs addressing. Conversely, if no code is present, this suggests that the issue may be intermittent or temporary. If B1825 is indicated, the next course of action will lead to further, more specific diagnostics. This process emphasizes the importance of continuous monitoring of DTCs throughout the troubleshooting procedure to ensure an effective resolution. In this fifth step, you check for DTCs using the Honda Diagnostic System, HDS, again, specifically looking for DTC B1836. The appearance of B1836 alongside B1825 could indicate a related issue, so it's essential to troubleshoot B1836 if present. This process ensures that all relevant DTCs are considered in the diagnostic approach and provides comprehensive insight into the power seat system. Processing multiple DTCs simultaneously can sometimes reveal intertwined issues that affect functionality. Hence, examining B1836 provides a deeper context for the diagnosis and directs technicians toward a more accurate troubleshooting path. During this step, you will again use the Honda Diagnostic System, HDS, to check for additional DTCs, specifically looking for B1826, B1827, and/or B1828. The presence of any of these codes in conjunction with B1825 suggests a more complex issue involving multiple elements of the power seat adjustment system. If any of these DTCs are indicated, it will guide the technician to specific troubleshooting procedures outlined for those codes. Identifying these associated error codes can aid in addressing systemic faults that may influence the functionality of the seat adjustment mechanism. Thus, it emphasizes the necessity of comprehensive diagnostics when dealing with potential malfunctions. In Step 7, the ignition switch is again turned to the lock position, 0, then back to the on position, 2. This step resets the vehicle's electronic systems, preparing them for the next phase of testing. Ensuring the ignition is properly cycled is pivotal, as it allows the systems to be in the correct mode for troubleshooting potential issues. Similar to previous steps, it's crucial that technicians accurately complete this action to eliminate erroneous results or failures during testing. The vehicle must maintain a stable power supply for the seat adjustment mechanism to function correctly. Once complete, the technician can proceed to operate the slide switch for further assessments of the motor's functionality. This step requires operating the slide switch for 2 seconds while observing the operation of the slide motor. This test aims to evaluate the motor's capacity to run smoothly and respond to the inputs from the switch. A smoothly operating slide motor indicates that the power seat adjustment system is likely functional. However, if the motor does not run as expected or shows signs of struggle, it suggests potential issues within the motor or related circuit connections. Observations during this test are crucial for determining the next troubleshooting pathway. An understanding of the operational behavior of the slide motor provides valuable information regarding the health of the entire power seat system, directing further diagnostic efforts. In Step 9, you need to turn the ignition switch back to the lock position, 0, to ensure that all electronic systems are powered down before proceeding. This action is essential to ensure technician safety and to avoid potential electrical shorts during service. Following this, disconnect the power seat control unit connector B, which comes with 40 pins. This disconnection will facilitate testing without any interference from the power supply. Preparing for continuity tests is key at this stage, as it allows for a diagnostic review of the electrical paths between components. Ensuring proper disconnection promotes accurate readings and minimizes systemic faults being overlooked. This step involves disconnecting the slide motor position sensor 5P connector, which is a critical action for inspecting the integrity of the circuit. By disconnecting this connector, technicians can focus on evaluating continuity between the power seat control unit and the slide motor. It's crucial to check for continuity between power seat control unit connector B's specified terminals and the slide motor position sensors terminals. This process helps identify any wiring issues, such as broken or shorted wires, that may contribute to the slide pulse error. Assessing these connections provides vital information regarding the reliability of the whole system. A lack of continuity may indicate the need for additional repair or replacement of faulty components. In this critical final step, technicians will check for continuity specifically between the power seat control unit connector B terminals 110 and 32 and the slide motor/position sensor terminals number 2 and number 3. Using a multimeter is crucial in this testing phase to confirm electrical continuity between these specified connections. If the multimeter indicates continuity, this suggests that the wiring and connectors are functioning as intended. Conversely, any inconsistencies or failures to indicate continuity may signal deteriorating wiring or defective components that need replacement. Proper verification ensures the integrity of the entire power seat adjustment system, validating that the slide pulse error issue has been comprehensively addressed and resolved. After completing all troubleshooting steps, it is imperative to conduct a final verification to confirm that all issues have been resolved concerning DTC B1825. This involves rechecking the system with the Honda Diagnostic System HDS for any stored DTCs. The absence of error codes suggests that the repairs conducted have rectified the slide pulse error and other associated DTCs, reflecting the reliability of the power seat system. Moreover, confirming the functionality of the power seat adjustment after all checks are complete is vital for ensuring both driver and passenger comfort. Regular verification plays a crucial role in ensuring that repairs have lasting implications for the vehicle, reinforcing the importance of meticulous diagnostic procedures. To prevent future occurrences of DTC B1825, it is important to implement a regimen of preventive maintenance focused on the power seat adjustment system. This can include regularly checking that the seat adjustments function seamlessly without hesitation. Regular inspections of the associated wiring can also help identify any early signs of wear or damage, which may lead to future electrical faults. It's necessary to ensure that all connections remain intact and free from corrosion or other damage that could impair functionality. Implementing these preventive measures significantly reduces the risk of encountering issues associated with the seat adjustment systems, contributing positively to the overall driving experience. In conclusion, DTC B1825 represents a slide pulse error that affects the power seat adjustment in Honda Odyssey models from 2011 to 2017. Through a systematic troubleshooting approach, it is vital to thoroughly examine each component relating to the power seat system, including the slide motor, sensors, and wiring connections. This error emphasizes the importance of precise diagnostics for effective repairs and ensuring reliable system functionality. Moreover, integrating established preventive maintenance practices aids in prolonging the lifespan of the power seat adjustment mechanisms, thus maintaining optimal vehicle performance. Ultimately, understanding and addressing DTC B1825 ensures a comfortable ride while enhancing overall automotive safety. Please like and subscribe to the channel. See you next time.